Good afternoon, everyone. I'm Purohit from Ahmedabad University. Today, I'm here to give a presentation on the topic virtual try-on for jewelry using computer vision, an innovative and cost-effective approach. I'll try to keep it as simple and straightforward as we have during the session after the lunch. But I will take you with the whole journey that how we develop this tool and this system using the computer vision. But before we commence with the presentation, I would like to express sincere gratitude to Ahmedabad University and IEEE Gujarat section for providing this opportunity and giving a chance to present in the AppsCon 2024. I would also like to thank Professor Sanket Patel and Professor Neil Roy for being a source of inspiration for my colleague and me in our research. And also today, my colleague Hrutika Patel is also here to present with me. So without further ado, let's begin with our presentation. So before we jump into how this tool, so let's have some brief introduction that what was the reason or the inspiration that brought us to develop this tool. So as we all are aware about the Industry 4.0 revolution and its impact in overall macro and microeconomic market changes, and it has also brought about changes in consumer preference as well on across various categories such as spectacles. Like, for example, if we all would be aware about Lenskart that in the platform itself they provide an experience of virtual try experience that you can try the spectacles at your at your own convenience without visiting the physical store. And so yeah, that's in the spectacles industry it was also provided. Then we have e-commerce kind of thing, like grocery shopping. Like earlier we have to visit to the grocery shop to do all the shopping necessary goods, but now it's in within few clicks, within few minutes we get all the necessary things. And apart from that, we had also in the clothing fashion as well in the Zara and also as well. However, there was a gap in the research for the jewelry segment, given that it's an industry that produces expensive goods. They're based out of an expensive metal such as gold, silver, platinum, and all those kinds of things. But therefore, with the 4.0 revolution, is also extended for jewelry segment. Hence, the consumer prefer to experience or try jewelry before making a purchase because they can't directly go to a e-commerce for the jewelry and buy that because they want to see how it looks on their body itself, right? So in today's fast-paced world, visiting a physical store is not that convenient, that feasible. So that is where AR, VR, virtual try-on system come into consideration. However, like a two sides of coin, it has its own challenges with AR, VR system. So to discuss with the challenges, first is the inability to use internet photos for virtual try-ons. So anyone would try to take a guess what would it mean with the first one, that is inability to use internet photos for virtual try-on. No one? Okay, that makes sense. So let's say you are going on a flight and or going to a journey, and then you're and you are reading a magazine, for example. And while reading a magazine, you find a good jewelry piece, and you say, "I want to try. I want to buy this. I like this jewelry piece. I want to see how it looks before I make a purchase." So, is there any tool that you are aware that you can click a picture and we can see how it looks on my body? So we can't do that. But however, there are few tools while we were doing the literature review and all those stuff. We found few tools where there are predefined 3D models existing, and you can use from those models. Also, you can only do the virtual turn based on those models. But it didn't provide the provision to do the virtual try on based on the internet photos that you want. So, so now considering from their point of view, if we want to add new jewelries, then it becomes after in a long run, it would be difficult in managing diverse models efficiently. So that is one of the challenge and the cost implication of 3D modeling in AR try-on. Basically, you would be having a designer, then you would be having while you want to do AR or VR try-on, you have to have the special hardwares to make that provision. So there is always the overhead cost and you have the maintenance cost as well that is attached with all the system. So this is where our tool comes into consideration, that we designed a tool or a system using computer vision, and that is it has three main advantage. The first is user-friendly and cost-effective solution. Second is that we don't require 3D models to be having in the system, or where you can directly use 2D images of the jewelry. So that's why it's superiority over 3D modeling and AR try-on. The third that it majorly focuses on the three broad categories, that is rings, bracelets, and earrings. So let's quickly go over the literature review that while we were doing this, developing this tool or this algorithm, we came, we went through the first traditional virtual try-on methods, then evolution of 3D body scanning and modeling, then impact of AR and VR on virtual try-on, and the last but not least, the rise of computer vision-based try-on. So let's quickly just give you the overview that how this tool or methodology is about the tool. So after establishing the context, let's dive into methodology. So first step is image pre-processing. That as we know that we would be clicking an image from any 2D magazine or something. So it is required to remove that extra or just do the segmentation of whatever the jewelry piece is. So as a first pre-processing, the user uploaded image undergoes pre-processing by removing the background for the jewelry, and this task was accomplished with the help of remove Python library. Then after, once we have the background removed, thereafter we did the media pipe integration. So depending on the jewelry category, we integrate the media pipe. So handmark detection library was used for rings, while posture detection was applied for earrings and bracelet. Then after once we have integrated the media pipe, we would be getting the coordinates where it needs to be placed based on the whatever the user has provided the information. So we do the object placement, that is using the detected desired points. The background image is overlaid and the objects is placed. The system also offers the ability to set the size of the jewelry because based on the finger size or whatever size it would vary from person. So there is a we have provided the provision to adjust the size and also rearrange the position if user feels that it is not to up to their expectation. So there is room for that as well. And lastly, this is entire process is executed in real time with continuous image feeding, and this was facilitated with the help of PIL and OpenCV tool. So this is just the result that here we have pre-assumed that image is already existing in the system. The first layer is pre-processing where the frames that we capture from the camera is there. Then basically we do the second step is the neural network model that is basically media pipe integration. Media pipe is built on the TensorFlow Lite, and in TensorFlow Lite in background it works on the neural network. So it detects the landmark positions. Thereafter, whatever the jewelry product or SKU has been selected, we can place that background image, and then that's the output result, and it is showcased to the user in the front end. So this is the simple interface that homepage and the categories that are available. Then after this is the interface image. The right hand side here you can see that the user can upload the ring or jewelry or the bracelet, whatever they wish of their choice. So it asks for four basic fields: name, description, the front side of the jewelry, and the back side of the jewelry. And then after this is the result. This is the live streaming going on. So in the left hand side you can see it is for the live streaming. That is for ring basically. So it has the size. You can adjust the size of the ring or the jewelry. Then after it gives the option of on which hand you want to try. It's a left or right based on the user preference, and along with finger and the offset as well in X and Y direction. And the top right is for the earring and the bottom right is for the bracelet. So conclusion is that with the help of computer vision, we provided with some realistic virtual try-on experience. Then we also had the size and fit adjustment options, which is kind of cost efficient in comparison to AR try-ons because we don't require any extra hardware. We just need one web browser. That's it. It would work. And the benefits for the users and retailers are like that the retailers can also have this kind of system if they want, or users can be used by at their own convenience. So this is one of the conclusions that we found, and we wish to offer this to the companies which not provide this kind of facilities like Amazon. Zara do provide, but still, if they want to integrate, then Tiffany and Co. So this is conclusion. As part of future work, we are expecting to do the expansion for more jewelry categories and continuous improvement and enhance virtual shopping experience. And also, we are trying to now deploy it over the cloud so it becomes open to all. So that's it in this present.